Good day, everybody. Once again, we are back together. Thank you for joining us on our YouTube channel. My name is Mlungisi Nkosi, and we are still continuing on that particular subject of probability. And of course, if you haven't subscribed, just hit that subscribe button, okay, and also hit the notification bell. Just to make sure that you are alerted every time that we are posting a new lesson. And please don't forget, just send in those comments and, just like the lesson immediately after you are finished watching. I want to make sure that, the algorithm works on our favor in this particular case. And of course, I'll continue to be your plug, always trying to simplify things when it comes to mathematics and physical science. All right, so let's get right into our lesson. So we're going to look at a scenario, and of course, I want you to kind of draw a conclusion, because they will not be telling us in the exam whether a scenario is dependent or independent. And I want us to kind of draw a conclusion together if this is a scenario where, we've got something that's dependent or independent, right? Now, let's get right into it. So they say to us, weather experts in a particular area have noticed that the probability that there will be rain tomorrow, and of course it's been raining in South Africa, so they say the probability that there will be rain tomorrow, if it is raining today, is 0.8. So do you see that? That the probability of it raining the next day is dependent on what was happening today, right? So if it rains today, then the probability or the chance that it might rain tomorrow is 0.8, okay, or which means it's 80%. And they say to us, and the probability that it will rain tomorrow if it is fine today. So meaning that if it's not raining today, the chances of it raining tomorrow is 0.3, right? Now they say it is raining on Friday. So let's assume this is a Friday, okay, whenever it is that you'll be watching this video. So let's assume it's a Friday today, right? So we want to check several things. They are telling us that it is raining today. So meaning that what should be the probability that it will be raining tomorrow, right? Which means on a Saturday, that will be 0.8, 80% chances, right? Now, what I want us to do is to draw, first of all, a tree diagram outlining this very scenario. We're going to start on the Friday. Okay, we'll come back to the question. Right, so in this case, let's say that, let's call, A, the probability that it will rain, right? Or, yeah, in this case, let's say, no, let's just call it R, okay? So let's say R, this is obviously the possibility of it raining, the possibility of rain. And of course, in this case, that would mean if we've got a possibility that it will not rain, that will be R prime, isn't it? Okay, so we always use that as it not raining, possibility of rain. I didn't finish that sentence. Right, now, so let's start on our Friday. They told us that on this day being a Friday, it is raining, right? So what that simply means is that the probability that it will rain tomorrow, which means on a Saturday, okay? So this would be on a Saturday, the probability that it will be raining tomorrow, which would be a Saturday, what is it? They said it's 0.8. So the probability that we would have rain in that case would be 0.8. Okay. Now, obviously, which means that there would also be a chance that it might not rain. Okay. So that would be what? R prime. So what are the chances that it might not rain? So this would be not rain, right? So what's the possibility? Or you can say A is raining and B is not raining. It's really up to you, right? So I'm just going to stick to R and R prime. So we know that R prime would represent the possibility or the chance of it not raining. So what's the chance that it might not rain on a Saturday, right? So in that case, remember the probability of R prime would be 1 minus the probability of it raining. So what would it be? You'd have 1 minus 0.8, so that would be 0.2. And of course, it makes sense. It's out of 100%. So if 80% are chances of it raining, then it means 20% would be the chance of not raining, right? So in this case, this would be 0.2. This would be on a Saturday. So this represents a Saturday. Now, let's look at a Sunday, okay? Now, if it rains on a Saturday, what are the chances of it raining on a Sunday? So now we are looking at Sunday. Sorry that I kind of, made it all muddled up there. Maybe let me just remove this for now. Okay, so let's look at a Sunday. If it rains on a on a Saturday, okay, we said that's 0.8. If it rains on a Saturday, what are the chances of it raining on a Sunday? So again, that would be 0.8, isn't it? So what are the chances that it will not rain on a Sunday? Okay. So that would be, in this case, 0.2. Okay. So that would be the possibilities of it not raining on a Sunday. Okay. That would be 0.2. So this would be R again. Or perhaps maybe let's not use R. No, we'll come up with something a little bit different, right? So in this case, the possibilities of it not raining on a Sunday, so that's R prime, that would be 0.2, right? Now, let's go back to Saturday. If it does not rain on a Saturday, right? Now remember, they said if it does not rain, okay, today, what are the possibilities of it not raining the next day? They said, well, it becomes 0.3, right? So in this case, if it does not rain on a Saturday, right, what are the probability, or what is the probability of it raining on a Sunday? Okay, so this would be on a Sunday. What's the probability of it raining? In that case, that would be 0.3, right? And then what would be the probability of it not raining? Now, again, we use the complementary rule in this case. So if the chances of it raining is 0.3, what's the probability that it will not rain? Okay, so in that case, the probability of it not raining would be 1 minus the probability of rain. In that case, that will be 1 minus 0.3. I hope I'm making sense with this. And that would give us 0.7. And so this would give us 0.7. So this is what our tree diagram looks like. Now, please keep in mind, this represents Sunday. These probabilities, represent both Saturday and Sunday. Now, what I want us to do is let's start looking at the questions. All right, now let's quickly have a look at, in fact, you know what? Let's do this for ourselves. Let's rather say, let A be the chances of it raining on Saturday, okay? Yeah, let A be the event that it would rain on Saturday. I want to do that. Okay, and then let B be the chances of it raining on Sunday. Okay, so remember, we said that this is a Saturday. This is a Friday. Today is a Friday, and they told us that it's raining today. So it would kind of be easy for us to represent this. So in a sense, I can say, well, this is A. This is the probability of A. Okay. This is the probability, of A. And this would be A prime. okay, instead of using R and R. Yeah, it just makes it that much more easier, because then we know that A prime just represents the just the Saturday. Okay, so that's 0.2. And in this case, we said B, therefore, would represent the chances of it raining on a Sunday. So that would be B. All right, so that would be B, and that would be B prime. Okay, the chances that it would not rain on a Sunday. So that would be B prime. And of course, again, this would be B. So that would be B. And that would be B prime as well. So instead of us calling this R prime, yeah, so that was the probability of A in that case, because we were talking about a Friday here. So that would be the probability of A. And here that was the probability of not A. And this is the probability of not B. Okay, right. Now, let's quickly have a look at it. In fact, so B prime here would be 0.2 again. And we said that's 0.3 and 0.7 respectively. Okay, now I think we are ready to answer the question. They say to us, what is the probability? So they are asking, what is the probability that it will rain on Saturday, right? Now, in this case, once again, remember we said it was raining on Friday. What's the probability that it will be raining on Saturday? So in this case, we are asking about the probability of A. So with simple, in this case, very simple to say that the probability of A raining on Saturday, that would simply be 0.8. We don't really need to make a fuss about that, right? And the second question they're asking, right? What will be the probability that it will rain on Saturday and Sunday, right? So we want to know raining on Saturday. So we are following. Okay, let me just make this in a different color. So raining on Saturday and raining on Saturday, on Sunday. So that would be A and B, right? So what would be the probability of A and B, right? So in that case, the probability of A and B, that would be the probability of A multiplied by the probability of B, provided that A occurred, right? Okay, in this case, so that would be 0.8 multiplied by 0.8. So remember, it's that probability of A multiplied by the probability of B in that case. So that would be the probability that it will rain on both days. Okay, I believe we'll get 0.16. We can just quickly verify that, okay, through our calculator. All right, so in this case, that would be how we would tackle B. All right, going to the next one. Actually, I just made a mistake on the previous one. So in this case, sorry, that is 0.64, not 0.16. So this would be 0.64. Right, now let's look at the possibilities of it. Okay, so the next one, they say to us, what's the probability that it will rain on Sunday? Now, I want you to please note in this case, we are simply looking at Sunday. Now, of course, there are two possibilities of rain on Sunday. And the first possibility is that it might rain on Saturday and therefore rain also on Sunday. All right, so it's that A and B there. But remember, it also might not rain on Saturday, okay, and rain on Sunday. Okay, so what's the real chance of it raining on Sunday? in this case. So it would be the possibility that in this case, if it rains, that would be the probability, but also it would be the probability of not A multiplied by the probability of B. So the real chance is those two combined possibilities, right? That it rains both days, but it also does not rain on the one day, but rains on the other day. So in this case, what we're simply going to do is that we're looking at this now. I want you to just quickly think about it. So you are simply saying the probability, okay? In fact, I just want to express this quite nicely, okay? So this would be the probability of right, the probability of it raining. So we are talking about the probability of B in that case, right? Right, so we're looking at the probability of B, and we are simply saying the probability of B would be, in this case, as we said, that would be the probability of A and B, and the probability of not A, so meaning that it does not rain, but it rains on Saturday, on Sunday. Right, so that would be the probability of A and B, okay, plus the probability of not A and B. All right, so in this case, remember, we've got 0.8 multiplied by 0.8 in that case, plus in this case, remember that the probability that it does not rain on Saturday, we said that was 0.2 multiplied by the probability that it rains. Remember, on Sunday, if it does not rain on Saturday, the probability of it raining on Sunday is 0.3. So we'll say multiplied by that 0.3 value there. Okay, so that would be 0.64 plus, in this case, 0.2 times 0.3. Okay, so that gives us 0.06. Okay, so if we add those two, 0.64, and we get 0.7. So the chances that it will be raining on Sunday, in this case, are 0.7. Okay, right. I hope that makes sense, ladies and gents, as we look at the last question. Right. So they say, what is the chance that it will not rain on Sunday? Of course, now we can actually, it's the second last question. Sorry about that. So what's the probability that it will not rain on Sunday? And you don't need to make it complicated for yourself. What we simply do is remember the complementary rule. In this case, we said, what's the probability that it will not rain on Sunday? So it would be 1 minus the probability that it rains on Sunday, which is the probability of B. So that would be 1 minus 0.7. And of course, this will give us 0.3. Okay. Right. I don't want to waste time with that one. Okay. Remember that complementary rule, right? Otherwise, what you would have done, if it does not rain on Sunday, it means that probability that it rains and does not rain. So you'll take A and B prime, and you'll take probability that it does not rain. So it would be A prime and B prime. So in that case, you'd say 0.7 multiplied by 0.2, and then plus, in this case, 0.8 multiplied by 0.2. Either way, you would actually end up at the same place. All right. Right. And then the last one, they say, what will be the probability that it will rain on Saturday or Sunday? Right? Now, in this case, I want you to please think about it, right? So every time that we are using or, remember that, we kind of are including all the possibilities. Now, in this case, we're saying if it rains on Saturday, or it would rain on Sunday, right? Either way. So I want you to think about it in this case. So the possibility that it might rain, now remember there's a difference between Saturday and Sunday, and there's a difference between Saturday or Sunday. Okay, now what we normally do, okay, in this particular case, or is a little bit of all right, let's look at that. So we say probability of A or B. Right, now we've got a rule in probability, right? And what it says is that when we take or, we can say, well, this is the probability of A plus the probability of B minus the probability of A and B. Okay, the probability of A and B. So this is a general rule in probability. Now, and of course, this works well when we've got independent events. Okay, these are dependent events, but we would still be able to apply it. It's just that we just need to be wiser around the probability of A and B, right? That it's not actually just the two probabilities multiplied by each other. But in this particular case, we can actually say that. Right, now what's the probability of A in this particular case? And I'll show you just another way in which you can look at that. So what would be the probability that it rains on a Saturday? In this case, we said that's 0.8, right? So remember that was 0.8. What is the probability that it rains on Sunday? In this case, we calculated that. We said, well, that's 0.7, okay? Right, and we subtracted that. What's the probability of it raining Saturday and Sunday? We calculated that and we said that gave us 0.64, and so that gave us 0.64. So if we add that, so that's 0.8 plus 0.7, okay, minus 0.64, and in this case I get 0.86. So that's the probability that I get. All right, and finally, what I want to do is to just show you the alternative way in which we could have calculated that, and you'll see that we'll end up exactly at the same place. Remember, now we are saying the probability of A or B, so it means it could either be Saturday or Sunday. Now let's go back to our diagram. Let me try and just remove all of these colors so that it does not disturb us. All right, now I want you to please have a look at it. Right now, probability that it rains on both days, right? That's definitely going to be inclusive of that solution, right? We said Saturday or Sunday, so Saturday and Sunday is inclusive of that, right? So in that case, that would be the probability that it rains on Saturday and Sunday, right? But again, we said Saturday or Sunday, so we can say, well, it might rain on Saturday, but it might not rain on Saturday or on Sunday. Okay, so that would be inclusive because remember we said or, right? So it's inclusive of that solution as well. So and then again we've got it might not rain on Saturday, but it might rain on Sunday. So that would be inclusive of that solution as well. So in this case, those are all our solutions, that it rains on Saturday and Sunday, it rains on Saturday but does not rain on Sunday, and it rains on or rather it does not rain on Saturday but it rains on Sunday. So that is inclusive of all of those solutions. So in this case, what we can say is that would be equal to the probability of A and B plus the probability of, now we said A, that is it rains on Saturday and it does not rain on Sunday, plus the probability that it does not rain on Saturday, but rains on Sunday. Okay, so the only one that is excluded there is if it does not rain at all on both days, right? So we can say, well, in this case, remember that was 0.8 multiplied by 0.8, plus in this case we had 0.8 multiplied by, if it does not rain on Sunday, I think that was 0.2. Sorry about that, I just need to go back. Yes, it does not rain, that's 0.2. Okay, and in this case, of course, if it does not rain on Saturday, the probability that it does not rain on Saturday, we said that's 0.2 multiplied by, okay, so if it does not rain on Saturday, right, going back, what are the chances that it might rain on Sunday? That would be 0.3. So that would be 0.2 multiplied by 0.3. And of course, we would include all of those solutions there. So that would give us 0.86, which is exactly the same answer as we got there. I hope that at least one of them does make sense to you. Okay, right. Another way that we obviously could have tackled it with, if it does not rain, the probability of it raining on Saturday or Sunday would be 1 minus, okay, the probability that it does not rain on both days. Okay, so you can say, well, in this case, that the possibility or the probability of A or B, okay, can also be 1 minus the probability of A and, not A and not B. Okay, so you can say this would be 1 minus, in this case, the probability that it does not rain on both days. So that would be 0.2 times 0.7. So 0.2 times 0.7. Right, so that would be 1 minus 0.2 times 0.7, and that would be 1 minus 0.14, which still gives you the same answer, which is 0.86. So I did this very deliberately to try and show you, obviously we're trying to be intentional that every single time you tackle probability, there's more than one way to skin a cat. Okay, so I hope that kind of made sense to you. All right, so I just want to leave this example here. I think it was a really, really nice example. And of course, we can look out for more. What I will be tackling next will be Venn diagrams. And of course, we'll be looking at contingency diagrams a little bit later on. Okay, hopefully by the end of this week, we will be done with probability and look at financial mathematics thereafter. All right, so from me for now, I will see you guys next time. Please don't forget to like the lesson, and please put on your comments on the comment section. Tell us if the lessons are indeed helping. Otherwise, I'll see you guys next time. Sharp, sharp.